Okay, now what I will do is I will discuss this concept of vertical circular motion. Vertical circular motion. When will you see this? Like suppose you have a string, you tie a small stone and you move it in a circle. So this is an example of a vertical circle. Another example is sometimes if you have noticed in these roller coaster rides, so you will have a roller coaster ride like this. So you have the roller coaster which will go like this, like this, like this, and then it will actually takes a turn and then again it goes on the inside of it, right. So this is an example of a vertical circle. You also have a similar thing going on when in aeroplane shows. In aeroplane shows, what they do is sometimes the plane wants to go like this and then it comes down like this. So this is also a case of a vertical circle. A very interesting application of this is that suppose you want to simulate zero gravity. Why do you want zero gravity? Suppose you want to do an open heart surgery and say for some reason you need to burst an artery. If there is zero gravity, understand that your blood pressure will be very low, and if the blood pressure is very low, the blood flow from the veins will be extremely low. So it kind of reduces bleeding during operations. So nowadays in certain cases they do some operations in zero gravity, and the easiest way to simulate zero gravity is for a body to be moving in a vertical circle, so that gravity becomes equal to the centripetal force. Then it appears that the net force on that is going to be equal to 0. Okay, so we will discuss this later on when you think about it, and if you want personally we can discuss that. Let's move on and then let's talk about this vertical circular motion. So now I have taken a point here, I have taken a point and then I have tied a stone to it. I have tied a stone to it and then I am taking it and I am driving it, or I am moving it in a vertical circle like this. Okay, so let us understand what happens. So to know what happens, first I will beautify this diagram a little. So this is the body. So this is what happens. So body is at different places at different times. Now when it is in this position, mg is acting downwards, tension will be acting upwards. So tension minus mg is the net force towards the center. So we have to understand this concept of centripetal force. What is centripetal force? See, whenever a body is to move in a circle, it requires a force to be acting towards the center. That force which acts towards the center is called the centripetal force. So in this, the net force which is acting towards the center is T minus mg. So T minus mg must be equal to mv squared by r. Now suppose a body was here, now mg is acting downwards, now tension is here. So understand that there is only one force which is acting towards the center, and that is tension. So that tension must be equal to mv squared by r. Of course the velocity here will be different from the velocity here. Why? Because as the body is going up, a part of the kinetic energy is getting converted into potential energy. If you look at it, what is the energy here? It will be only kinetic. What is the energy here? It will have both kinetic and potential energy. Then when it reaches here, what will happen? It should have mostly potential energy, but we are saying it will also have some kinetic energy. Now why should it have kinetic energy here? Because T plus mg is equal to mv squared by r. Now for some reason tension may be 0, but even if tension is 0, this mg won't become equal to 0. So what will happen? So that v will become equal to root over of rg, which means that if a body is to move in a vertical circle, whatever happens at the topmost point, it should have this velocity. If it has less than this velocity, what will happen is it will fall down. If it has 0 velocity, it will just fall down. If it has less than this velocity and a parabolic path, it will fall down. Okay, so whatever happens, if the stone has to, technically this word is called, it is called loop the loop. Technically, if the stone has to loop the loop, looping the loop, if the stone has to loop the loop, the minimum velocity that it requires here is root over of rg. Now assume that this is the case. Let's find out what is going to happen in the rest of the points. So now we are going to assume this is the case and then try to find out what will happen at the different points. Okay, so we'll just take a short break and then we'll work. Okay, so let's continue with what we were doing. So we said at the topmost point the velocity v is equal to root over of rg. Now understand that this distance that we are talking of is r, and this distance is also r. So from this particular point the body has gone up by a distance of 2r. So there will be an increase in potential energy mgh. So mg into 2r will be the increase in potential energy as it moves from here to here. Similarly, when it goes from here to here, the change in potential energy will be another mgr, right? So now let us incorporate all these things into our arguments and then let us see what happens. Suppose I am doing a vertical circle at the 3 o'clock position. This is the 12 o'clock position, this is the 6 o'clock position, this is the 9 o'clock position. Here velocity is equal to root over of rg. If the velocity is root over of rg, what is the kinetic energy equal to? Half into m into v squared. So that will give you half into m into r into g. Now what is the potential energy here equal to? Potential energy is equal to 2 mgr. So the total energy will become equal to potential energy plus kinetic energy. So that will become 2 mgr plus half mrg. So when I add both of them, it will become 5 by 2 mgr. So at this point the total energy is 5 by 2 mgr. That means what? That only if the body has a total energy equal to root over of 5 by 2 mgr will the body reach the maximum height. That means here when we are saying kinetic energy, what should the kinetic energy be equal to? Kinetic energy should also be equal to 5 by 2 mgr. Only then will the body reach here. At this point, what should be the potential energy equal to? mgr. So the potential energy is mgr. What is the kinetic energy equal to? Understand the total energy is 5 by 2 mgr. Out of that 1 mgr is here. So how much will this be? 3 by 2 mgr. Here also the potential energy will become equal to mgr and the kinetic energy will be equal to 3 by 2 mgr. Are we able to understand? So now if we let's look at this point. In this case, see, tension is in the upward direction, mg is in the downward direction. So I have T minus mg is equal to mv squared by r. But how much is mv squared by r? I know this is equal to half mv squared. So 2 will get cancelled. Mv squared is 5 mgr. So that will become equal to 5 mgr by r. The rr gets cancelled. So T will become equal to what? 6 mg. That means the tension when it is at the lowermost point is equal to 6 mg. How did I get the tension? I said T minus mg is equal to mv squared by r. Understand, whatever you do, you cannot get rid of mg. So the tension is in the upward direction. So T minus mg is equal to mv squared by r. If I make my substitutions, I will get T is equal to 6 mg. That means at the lowermost point, the stone, the tension in the rope is 6 mg. At this point, I will see that tension will become equal to what again? Mv squared by r. So tension is equal to mv squared by r. I will see that it will become equal to 3 by 2 mgr is equal to half mv squared. 2 gets cancelled. So mv squared is 3 mgr. R goes down. So I will get mv squared by r is equal to 3 mg. So the tension here is 3 mg. We found out that the tension here, if the minimum tension here is 0, then the velocity is equal to root over of rg. That was the condition. So at this point the tension is 0. At this point the tension will be again equal to 3 mg. Okay.